Hi, and welcome back. This note-taking guide is going to continue on with family of functions graphing. And today we're going to be talking about transformations. And a transformation of a function simply shifts that parent function or moves the parent function to another location on the coordinate plane. There are two types of transformations. The first one is a translation. And next we have reflections that we're going to deal with. A translation shifts the graph up, down, left, or to the right. Where a reflection flips the graph across a line such as the x or y axis. Before we begin looking at how this works, let's take a minute, stop, and review our family of functions, their parent functions, and the general shape of their graphs. First, the linear function parent function is f of x equals x, and its graph is a line through the origin. Absolute value has a parent function of f of x equals the absolute value of x, and its graph is a v going through the origin. Now, rational functions vary a lot depending on the complexity of the functions in the numerator and the denominator, but we're going to just look at f of x equals 1 over x, or 1 divided by x, and that graph has a section in the upper right quadrant and the lower left quadrant. Looking at logarithmic functions, I've got f of x equals the log of x, and its graph begins almost a steep steady rise, and then it takes a turn for the right, so it goes below 0 on its range. Square roots, on the other hand, we have f of x equals the square root of x, and its function starts at the origin and goes to the right, does not go down below into negative values. Exponential has an exponent as a variable, or a variable as an exponent, I should say, and its function, the graph, begins here, kind of has a slow, and then it takes off for the moon, takes a turn upward. Power functions have two parent functions, one for even functions, so I have x squared, and its graph is the parabola. Then I have my odd exponents, and they all model x cubed as a parent, and it starts upper right, does a little hitch in the center, and then comes down on the left. So a quick review of our parent functions and their graphs. Now let's see what happens and what makes them move around the coordinate plane. To move a function or a parent function up, we're going to have a constant c that is added to the outside of the function, or f of x plus c means that the graph is translated or moved up, whatever that constant is, c units. So let's look at an example and just try and translate this and see what it means. First part says sketch the graph of the parent function f of x equals x squared. And once again, sketching the graph, I don't have to do exact points. What I'm going to be looking for, or coordinates I should say, is the general shape of the graph. So my even powered functions, I know that is a parabola shape, so I'm going to put that in. Next, I'm going to look at g of x, which is x squared plus 2. Notice that the plus 2 is outside the function. It's not in here with that square. That tells me I'm going to move my parent function up 2 places, 2 units, and that's going to be my origin, but my general shape stays the same. So the red line is x squared plus 2, and the black line is just simply x squared. So outside added moves up. When a constant, and once again c, is subtracted from the outside of a function, it's going to have f of x minus c. The graph is translated or moved down c units. Once again, we're using our power functions that are even. So my parent function, f of x equals x squared, simply going to sketch that in. And then I'm going to notice I have x squared minus 2. And once again, my constant is subtracted outside the function. It's not with that x squared. That tells me my origin moves down 2 units, but my general shape of that parabola stays the same. So here I have x squared minus 2 as my red line, and x squared is my black line. So added to the outside of the function, it moves up that many units. Subtracted from the outside, it moves down that many units. Now, when we have a constant h is added to the inside of a function, we're going to have f of x plus h inside whatever type of function that is. The graph is translated left h units. Now you would think because we've added we'd be moving to the right, but it's actually the opposite direction when it's inside the function. So we're going to move left that many units. So my graph, and once again I didn't erase very well, let me take care of that. Hang on. First, let's start by graphing the parent function, f of x equals the absolute value of x. That parent function begins at the origin and is a v. Next, we're going to notice that I've got plus 2 inside those absolute value symbols. So that tells me I need to move this graph to the left 2 units. Doing so, I just go left 2 spots, put my, whoops, I had my finger down on there, my origin here, and the general graph shape stays the same. So this is the absolute value of x plus 2, where the black line is simply the absolute value of x. When we have a constant h and it's subtracted from inside the function, it's going to be f of x minus h. the graph is translated right h units. Once again, the opposite of what you would think. You would think if I subtract it, I'm going left, but it's the opposite. You go right. So let's begin by graphing our parent function, f of x equals the absolute value of x. It's a v beginning at the origin. So this is the absolute value of x. F of x equals x minus, the absolute value of x minus 2 tells me to move right 2 places, which puts my vertex on the right side, and my general shape remains the same. So this is the absolute value of x minus 2. A little confusing. So if you think outside moves in the direction you would think, inside goes in the opposite direction. We'll work on this a little bit in class and practice and make sure we know which way things are moving, left, right, up, or down. That's the end for this video. In our next video, we're going to be working on reflections and then recapping and combining some translations. See you soon.